Welcome to your flipped classroom for lesson 3.6. Let me start by apologizing for making you do this over the weekend. However, the material covered in lesson 3.6 is brand new material. Due to our new curriculum, you were not taught this information last year, and so this is the most difficult lesson that we have done to date, and I wanted to put it in this format so that you had time to go at your own pace. You can pause, you can write extra notes, you can rewind if you don't understand something I say. And so that's why I wanted to do that this way. And I'm saying all of that because I need you to make sure that when you sit down to do this lesson that you are free of distractions. This lesson has taken me hours to prepare the PowerPoint, to get the worksheets, to even record the lesson. I've had to prepare and make sure that I am very clear on what it is I'm trying to get you to understand. So this is a more difficult lesson. It is going to take your concentration. So please make sure when you're sitting down to do this that you are free of all distractions. You can see from the title that we're going to learn about transformations of graphs of linear functions. Now the good news is for a week and a half we've been working with functions and the graphs of linear functions. So hopefully by now you know when we talk about graphs of linear functions that we are talking about lines. We have learned how to graph lines in standard form, slope-intercept form, and so now what we're going to do is we're going to take lines and we're going to transform them. We're going to do different things to these lines. And so our essential question for this lesson is, how does the graph of a linear function f of x equal x compare to the graphs of g of x equals f of x plus c and h of x equals f of c of x? So probably right now you look at that and are pretty confused, but hopefully by the end of this you'll be thinking, oh, I know what transformation that represents. Okay, but it starts with your parent function, understanding what a parent function is. And you can see here that I've written f of x equals x. Now, here's how I'm going to refer to f of x and x in this lesson. First of all, I want to remind you that f of x is equivalent to the variable y. Hopefully you have learned that by this point. Y, we also have called our output values. And of course, x is our input. So you're going to hear me refer to output and input. So I need you to remember, output is my y values or my f of x. X is my input. Now, the parent function is the most basic of your functions. And so what we're going to do is we're going to take these parent functions and then we're going to transform them. And transformations do a couple of things, and I want you to make sure you fill in the blanks. They change the size, the shape, the position, or the orientation of a graph. Now, one transformation isn't necessarily going to do all of those things, but the different transformations that we're going to look at today, they either will change the size, the shape, the position, or the orientation of a graph. So let's look at the different types of transformations. The first one is a translation. So translations simply take our graphs and shift them horizontally or vertically, but do not change the size, shape, or orientation. So translations, let me say this again, shift your graphs horizontally, that's right or left, or vertically, up or down, but do not change the size, shape, or orientation. The second type of transformation that we're going to look at are reflections. Now reflections, we flip the graph over a line called the line of reflection. And in this lesson, we're going to talk about reflecting lines over the x-axis or the y-axis. Probably the most difficult transformations that we're going to talk about, the most difficult to really wrap our minds around and visualize, is going to be the horizontal shrink and stretch. Now again, let me remind you, the horizontal axis is the x-axis and the vertical axis is the y-axis. So as you're reading these definitions, it's almost like you have to think opposites. So for a horizontal shrink or stretch, the graph shrinks toward the y-axis or stretches away from the y-axis. Look at your vertical shrink or stretch. The graph shrinks toward the x-axis or stretches away from the x-axis. So Again, you've got to think opposites here. My vertical axis is my y-axis, but if my graph shrinks towards the x-axis, it's a vertical shrink. And if it stretches away from the x-axis, it is a vertical stretch. All right? Now, grab that cheat sheet, and I want you to start off by writing the parent function at the top of this column. So we're going to go ahead and write f of x equals x again, because I want you to remember the parent function is this simple. We could pick any value of x that we wanted to, and we could graph a line. But we're not going to do that. I just want you to see the f of x equals x, because as you look down that function column, you see they've made changes to the x in parentheses, or they've made changes to the f of x. So we're going to go through this slowly, and this cheat sheet needs to be kept in a very safe place because we're going to use it in class on Monday when we do the activity that goes with this. We're going to reference it a lot until you get used to this information. So make sure you make any notes on this paper that I make, and make sure you keep it in a very safe place. All right, let's look at, and remember, I'm going to refer to f of x as my outputs, and I'm going to refer to x as my inputs. So let's look at a horizontal shift. Now, I already mentioned this, but remember, horizontal is right or left. All right, my x-axis is my horizontal axis, and a horizontal shift is either right or left. All right, so look at the function. When we have a horizontal shift, you will notice that they are adding or subtracting something to the input value. So look at what they did. They went inside of the parenthesis where the x was, and they have either added a number or they have subtracted a number. So here's what we're thinking. They have done something to my input. When they've done something to my input, they've done something to my x values. Well, that's my horizontal axis. So the shift is horizontal, okay? Unfortunately, we got to think opposite again. If they are adding something to my input, my shift is left that many units. If they are subtracting a value from my input, they're shifting right that many units. So the reason that might be a little confusing is because on an x-axis, when a number is positive, the move is to the right, and when a number is negative, the move is to the left. Right? But because of a formula, when they are adding something to the input, you're shifting to the left, and when they're subtracting something from the input, you're shifting to the right. So be really careful. But hopefully you can see that the change is to the x, to the input value. Now you're like, not really sure I see that. All right, let's look at the vertical shift. Remember, vertical is up and down. Okay, so keep that in mind. Now look, this time they have added something to the outputs, or they have subtracted something from the outputs. You see how f of x is still intact. They have added something to f of x, or they have subtracted something from f of x. So this one actually is pretty simple, because if I have added something to the outputs, my shift is up. If I have subtracted something from the outputs, my shift is down. So we're looking, have they gone inside the parentheses and added something to the inputs, the x, or have they just added to the outputs or the y values? All right, hopefully you're with me. Now we're going to practice these, but let's just keep breaking these down. Now, a reflection is a different type of transformation. But again, I want you to look. Have they changed the sign of the outputs, or have they gone inside the parentheses and just changed the sign of the inputs? Let's look at this one. They have changed the sign of the f of x. They have changed the sign of the outputs. So again, we're going to think opposite. If f of x is equal to y, this is a reflection across the x-axis. And look at this next one. In the next one, they went inside and they changed the sign of the x, or the inputs. So It's opposite. This time they're reflecting across the y-axis. So this is why I've provided you with a cheat sheet, because right off the bat, some of this is going to be very confusing. Hopefully the more you're looking at it and the more you're putting it into practice, it's eventually going to be a piece of cake. All right. Now, we talked about the vertical stretch, and this chart calls it a compress. I want you to cross out compress, and I want you to put shrink. And I want you to go do the same thing for the horizontal stretch and compress. We're going to change it to the word shrink. Compress is the same thing, but our book uses shrink and not compress. So go over here to the other column as well and change it to the word shrink. So we're crossing out compress and we're changing it to the word shrink. Awesome. Now, I want you to look at A. We are going to be calling A scale factor. All right, A is a scale factor. So, when we multiply the outputs by a scale factor, so you can see right here, again, I am multiplying A by f of x here and here. All right, so when I am multiplying the outputs by a scale factor, it is a vertical stretch or shrink. Now again, hopefully that's easy because f of x is the same thing as y, and my vertical axis is my y-axis. So if I am multiplying my outputs by a scale factor, it's either a vertical stretch or a vertical shrink. Now this is where it gets complicated because A can either be a number greater than 1 or A can be a value between 0 and 1. So this is where it gets tricky. If A is greater than 1, it is a vertical stretch. Okay? If A is greater than 1, it is a vertical stretch. If A falls between 0 and 1, now guys, numbers between 0 and 1 are fractions. So if you're multiplying the outputs by a fraction, a value between 0 and 1, now it's a vertical shrink. Now let's look at the horizontal stretch and the horizontal shrink. This one is the most difficult because look at this. The scale factor now goes inside and is being multiplied by the inputs. So hopefully that is really starting to jump out at you. The scale factor A is now inside the parentheses and is being multiplied by the inputs. Okay, same thing here. When my scale factor is being multiplied by the inputs only, it is a horizontal stretch or shrink. Now again, hopefully that makes sense because my inputs, my x, that's my horizontal axis. So here's where it gets tricky. Look at this one. This is the, again, where we got to think opposite. If A is greater than 1, if A is greater than 1 on a horizontal stretch or shrink, okay, if A is greater than 1, it's actually a horizontal shrink by a factor of, look at that, 1 over A or 1 divided by A. So we would actually have to take our A value and put it underneath 1. When we wanted to write down this is a horizontal shrink by a factor of and fill in the blank, we'd have to take that A value and put it over or divide it, 1 divided by that value. So when A is greater than 1, it's a horizontal shrink. And then again, when A is between 0 and 1, so we're talking a fraction, this time it is a horizontal stretch. But again, look at that. It's a horizontal stretch by a factor of 1 divided by A. So we're going to have to take a fraction and we're going to have to say 1 divided by that fraction in order to find the scale factor. So again, this is where it gets a little bit tricky. All right, but that's okay. Like I said, we're going to practice this, and we're going to use this cheat sheet until we just get really, really good at this. Now, I want you to keep this cheat sheet right there with you, because we're going to get into our examples here, and I want you to be able to reference that cheat sheet as much as you need to. So let's look at example number 1. It says, use the graphs of f and g to describe the transformation from the graph of f to the graph of g. Now remember, as you read these instructions, we always want to make sure we understand what the instructions are asking. Keep in mind when they're talking about the graph of f, that's the parent function. And I added that note for you. F of x is the parent function. All right, so just keep that in mind. The g is going to be the new function. That's the function where we are going to look and figure out where the transformation took place. What was the transformation? What did they do to the parent function? All right, so let's look at letter A. I gave you a graph because I wanted you to be able to visualize what a graph looks like as the parent function and what the graph looks like when it has a transformation done to it. So I want you to focus on the f of x equals negative 2x. All right, this is considered our parent function. Now, if you look at, and I know it's a little bit blurry, but this says g of x equals f of x plus 2. Okay, g of x equals f of x plus 2. Now, let's do this. Without even looking at that new function, look at the black line and look at the red line. What did they do to that black line? Did they move it to the right? Did they move it to the left? We know it's a translation because nothing has changed about that graph except its location. It's not bigger, it's not smaller, it's not in a weird position. It just has moved over. So the question is, did it move over to the right or left? Or did it move over, which technically up or down is not possible. So I pretty much gave it away, but we can see that it moved to the right. Okay, it moved to the right. Now, does anybody see anything wrong with what I just said versus what the equation of the new function says? Because if we look at g of x equals f of x plus 2, the question we have to ask ourselves, did they add something to the x, to the input values, or did they add something to the y values, the f of x? And if you look at that function, and if you look at your cheat sheet, they have clearly added 2 to f of x, which is y, which is our y values. So if you're looking at your cheat sheet, when they add something to f of x, it is a vertical shift. And since they added 2, it is a vertical shift up 2 units. So the graphs can be deceiving. And this is why I wanted to show you the graph, but I want you to be careful because sometimes just looking at the graph can be deceiving. It looks like they took that graph and they just shifted it over one. But if I'm looking at the equation of that function, that's not what they did. They actually took that line and they shifted it up 2 units right here. So I want you to be very, very careful because this can be tricky. So that's why I want you to have that cheat sheet in front of you, and I want you to be looking at and interpreting those new functions. Now, as far as an answer goes, we write down a vertical. This is a vertical translation. Two units up. And you can box in that answer. All right, now let's move away from the graph and let's just try to focus on the parent function versus the new function. All right, and you're gonna notice that I tried to highlight the parent function and then I tried to highlight the parent function in the new equation. All right, if f of x is equal to 2x minus 1, that's my parent function. Okay, really I'm not focused on the 2x minus 1 for any reason other than that's what the parent function is. Okay, now go look at g of x. I highlighted f of x for you. So again, the question is, did they add or subtract something to the y values? Or did they go inside the parentheses and just add or subtract something from the x values? And again, hopefully you're remembering f of x is the same thing as y. So they are adding 3 to the y values. So let's go to our cheat sheet and let's see what happens when they add something to f of x. When they add something to the output values, again, it is a vertical shift up. It's a vertical shift up. And again, the y-axis is my vertical axis. So hopefully I can remember this. It's a vertical shift. And since they added 3, it's a vertical shift 3 units up. Why is it 3 units? Because that's what they did. They added 3 to that original parent function. So it is a vertical shift 3 units up. Now I want you to take a minute. I want you to look at letter C. We have f of x equals 2x minus 1. Again, same parent function, but now look where the change came. The change came with the x. They went inside the parentheses and they've added 3. So my first thought is they're adding something to the x values, so that is a horizontal shift. All right, that's a horizontal shift because they're adding 3 to just the x values. So that's a horizontal shift because my x axis is my horizontal axis. Now, remember horizontal, I got to think opposites. Normally adding 3 would go right. Okay, positive values on the x-axis go to the right, but we're thinking opposite. So since it's a horizontal shift, it is a horizontal shift 3 units left. 3 units left. And again, if you're looking at your cheat sheet, you see that very clearly. When it's f of x plus h, they say it's a shift left. A shift left. So you just got to get used to thinking with horizontal shifts opposite. If they're adding something to x, they're shifting left. If they're subtracting something, they're shifting to the right. Now, I apologize for the printing. The example 2 instructions are actually at the bottom of that first page. Okay, grab your cheat sheet. I'm going to remind you that before every example because I want you to make sure you have that cheat sheet in front of you. All right, example 2 says use the graphs of f and h to describe the transformation from the graph of f to the graph of h. Now, just your reminder again, f is your parent function. So again, I wrote that down in the notes. F of x is the parent function. What is being done to the parent function? So let's look at letter A. Keeping in mind f of x is the parent function, so that's where our focus, that is the line that something has been done to it. Something has been done to it, and we have to figure out what. Again, if you look at this graph, it's really hard to tell. It's really hard to tell what has been done. So that's why we're going to rely really heavily on right now looking at that new function and what have they done. So you notice, hopefully, they have gone inside the parentheses and they have changed the sign of x. They have changed the sign of your input values. So if you're looking at your cheat sheet, when they go inside and change the sign of your x values, it's a reflection. And again, we're thinking opposites. Since they've changed the sign of our x values, it is a reflection in the y-axis. It's a reflection in the y-axis. A reflection in the y-axis. And that's the answer you're going to box in. So the transformation this time is a reflection. Might not look like it, but this is a reflection of the parent function. All right, now let's move away from the graph and let's look at letter B. Again, my parent function is f of x equals negative 5 minus x. So for the new function, again, notice they have gone inside the parentheses and they have just changed the sign of my x values. So again, since they're changing the sign of my x value, that is a reflection. Changing the sign is a reflection, and it is, again, think opposites, it is a reflection in the a reflection in the y-axis, just like letter A, because they have gone in and they have changed the sign of the x values. So it is a reflection in the y-axis. Now take a minute and see if you can figure out letter C. The parent function is f of x equals 1/4 x minus 2. The new function says h of x is equal to the opposite of f of x. So hopefully this time you've already seen they have changed the sign of the outputs. They have changed the sign of the y values. So changing the sign is a reflection. And since this time they have changed the sign of the y values, the outputs, this is a reflection in the x-axis. A reflection in the x-axis. So, reflections, you're looking for them to change the sign of either the x values or change the sign of the y values. All right. Example number 3. Use the graphs of f and r to describe the transformation from the graph of f to the graph of r. So one more time, remember f is the parent function. And I wrote it down for you one more time. F is the parent function. So let's see, if we're looking at this graph, again, we see the black line is the parent function, f of x equals 3/2 x minus 1. And something has been done to that function. The graph, we might have some speculations about what's been done, but let's look at the new line. R of x is equal to 2 times f of x. Now, if we're focused, we can hopefully see that they are multiplying the f of x by a scale factor. They are multiplying the y values. And we know that if they are multiplying the y values, that is a vertical shrink or stretch. Okay? This is one where we don't have to think opposites. If they are multiplying the y's or the outputs by a scale factor, it's going to be vertical. Now let's look at our cheat sheet. Okay, we know it's vertical because the outputs are being multiplied by a scale factor, and our scale factor is a 2. So according to our cheat sheet, if a is greater than 2, it is a stretch. It is a stretch. So this is a vertical stretch by a factor of, and for vertical, it's just a is a. So it's a vertical stretch by a factor of 2. Since our a value is 2, it is a vertical stretch by a factor of 2. All right, now let's move away from the graph. Let's look at letter B. F of x is equal to negative 2x minus 4. And r of x is equal to f of 1/2 x. 1/2 x. Now, first thing you might notice is the notes look different than the screen. So let's make that change. Somehow, when I copied and pasted onto the Word document, it got switched around. So I need you to cross out letter B, and I need you to change it. All right, what you see on the screen in front of you is the problem that you should write down. So f of x is equal to negative 2x minus 4, semicolon, r of x is equal to f of 1/2 x. That's the actual problem that we're going to work. So you can cross out the one that's on your notes and you can replace it with the one you see on the screen. Now, hopefully you're noticing that the x values have been multiplied by a scale factor. So looking at my cheat sheet, if I still need to look at my cheat sheet, when the x factors are multiplied, when the x values are multiplied by a scale factor, that is a horizontal stretch or shrink. So let's go ahead and write down horizontal, because we know that they have multiplied the x values by a scale factor. So now we just have to decide, is my a greater than 1 or is it between 0 and 1? And hopefully you can see very easily that 1/2 falls between 0 and 1. When that is the case, it is a horizontal stretch. So let's go ahead and write down that it's a horizontal stretch, because this is where it gets tricky. It's a horizontal stretch by a factor of 1 divided by a. 1 divided by a. So be very careful. We can't just put by a scale factor or by a factor of 1/2. We can't, because the trick is it's stretch horizontally by a factor of 1 divided by a. So we're going to have to do a little bit of extra math. We're going to have to do 1 divided by our scale factor, which is 1/2. So if I stick that in my calculator, 1 divided by 1/2 actually equals 2. So this is a horizontal stretch by a factor of 2. Is your mind blown? Because I know mine was. All right, so it's horizontal because they're multiplying the x values by a scale factor. It's a stretch because the scale factor is 1/2, and that falls between 0 and 1. But then I have to take that a, and I have to actually do 1 divided by that value to get the actual factor. So it's a horizontal stretch by a factor of 2. Hopefully you are seeing why this cheat sheet is so wonderful right now. All right, now look at letter C. You're going to have to make a change to letter C also in your notes. I'm not really sure how this happened, but you have the first part correct. F of x is equal to 1/4 x minus 2. And actually, I just noticed it's a negative. That should be a negative. So make that change in your notes. F of x is equal to negative 1/4 x minus 2. And then, of course, you're going to cross out the h of x equals f of x and change it to r of x equals 4 times f of x. So go ahead and take a minute and make that change. Now, we see the parent function, and hopefully you are getting so good at this that you see very quickly that my f of x, my y values, are being multiplied by a scale factor. So either with or without your cheat sheet, when the y values are being multiplied by a scale factor, it is a vertical shrink or stretch. So let's go ahead and write down vertical. The scale factor, the y values are being multiplied by 4. So if we look at our cheat sheet, when a is greater than 1, it is a stretch. So again, this is a vertical stretch. And the good news about vertical shrinks and stretches, what you see is what you put in your answer. So it is a vertical stretch by a factor of 4. And that is what you are going to box in. And these are transformations that are vertical or horizontal stretches or shrinks. And you notice it just so happened that all of these were stretches. But hopefully you are now understanding how to look and find whether it's a stretch or a shrink. I'm proud of you for staying with me so far. We've got one more example, and this is where, once again, grab that cheat sheet because it's going to be very helpful for this last example. Okay, it says, write the function g in terms of f so that the statement is true. Now, the first thing we've got to interpret is write the function g in terms of f. Write the function g in terms of f. That means my problem is going to begin with g of x, and it's going to equal the f of x. All right, so we're going to write our new, basically we're going to write our new function. Okay, we're not going to write the parent function, we're going to write the new function. So let's really dissect this. It says the graph of g is a horizontal shrink. So let's go to that cheat sheet and let's find horizontal shrink. We know that when there's a horizontal shrink, the x values have been multiplied by something greater than 1. By something greater than 1. So let's start by doing f, and let's go in the parentheses, and we can put x, but let's leave a space because a horizontal shrink means that they have gone inside the parentheses and they've multiplied x by something. Now, it's a horizontal shrink by a factor of 2/3, and this is where it gets tricky. But if we look at our cheat sheet, remember, a shrink horizontally is by a factor of 1 over a, 1 divided by a. So we're going to take 1 and we are going to divide it by 2/3. Now again, if you stick that in your calculator, 1 divided by 2/3 actually becomes 3/2. And you're thinking, wait, but that's a fraction. Right, but 3/2 is equivalent to 1.5. Isn't 1.5 greater than 1? So a horizontal shrink means that the input values, the x values, have been multiplied by a value greater than 1. So we take that 2/3, we plug it into that little formula, 1 divided by a, and it gives us 3 over 2, which is 1.5. But we're just going to plug 3 over 2 right there in front of x. And we're done. That is the new function. If the parent function has had a horizontal shrink by a factor of 2/3, then this is what the new function looks like. Now you see how helpful that cheat sheet is? So I said keep it in a really safe place. All right, last one and we're done. The graph of g is a horizontal translation. So again, if you need that cheat sheet, we know that a horizontal translation means, and again, we're starting with g of x, it means, again, that they have done something to the x value. So let's put f of, this time, it's either x plus 5 or x minus 5. Now remember, horizontal translations, we got to think opposite. This says 5 units left. When we think left on the x-axis, we normally think negative. But with translations, if it's 5 units to the left, it actually means plus 5. But that's it. It was a horizontal translation, 5 units left. And that is your final answer. Now, like I said, this is tough, and I understand that. So keep this cheat sheet, put it in your test and quiz folder. Make sure you have it with you on Monday because we're going to do more activities. The more you practice this, the better you're going to get. The more I've practiced this lesson and these problems, the more understanding I've gained myself. So practice is going to make perfect in this scenario. So please make sure that you have filled in all these notes. Make sure that you have that cheat sheet, and I will see you on Monday. Oh, and by the way, I want you to go to the top right-hand corner of the front page. All right, so the page that has the date and the lesson. Go ahead to the top right corner, and on a scale of 1 to 10, being 1 is I get this, I know exactly what I'm doing, to all the way to 10, where 10 means I have no clue what I'm doing. Give me where you fall on that scale from 1 to 10 as far as this lesson goes. All right, guys, I'll see you on Monday.